Let's talk now about the negation of a conditional statement. And you may recall from chapter 2 that the negation of if-then statements is going to be a conjunction. It's similar over here. The only difference is that we have to also negate the symbol in front. For all becomes an existential. And again, to negate P implies Q, you just leave P alone and you put an and symbol and then you negate the predicate Q. This is very similar to what we did in chapter 2, like I said just now. Let's practice that with the example. For every person P, if P is female, then P has blue eyes. So remember, I'm looking for the negation, so I'm going to start by negating the for all statement and end up with an existential statement. And also don't forget that the negation of the conditional is going to be an and statement, a conjunction. So my work might look something like this, starting with the original statement and the tilde because I want to negate. I'm going to end up with there exists a person P such that, and now I'm looking for the negation of the statement that comes afterwards. The statement that comes afterwards is an if-then statement, and to negate it, all I have to do is figure out the P of X and the Q of X, put an N in the middle, and negate the Q of X. So my work may end up giving me something like this. There exists a person P such that P is female and P has no blue eyes. In other words, some female person doesn't have blue eyes. Similarly, if I want to negate all discrete math students at Southwestern are athletic, there are different options. I can begin by rewriting the problem as an universal conditional statement, for instance. So I could start by saying for every X at Southwestern, that's the domain, discrete math X, meaning if X is a discrete math student, then athletic X, meaning X is going to be athletic. And the negation in this case would be there is some X at Southwestern such that they are in the discrete math class and they are not athletic. Another option would be something like this. All discrete math students at Southwestern are athletic can be reinterpreted as for every X who is in discrete math student at Southwestern College, comma, athletic X. Therefore, the negation would be that there exists a student who is in discrete math at Southwestern College such that the person X is not athletic. So some discrete math student at Southwestern is not athletic. Both options lead to the same solution. It's just one of them uses an if-then statement and kind of combines the domain and P of X together, whereas the first command or the first option separates the domain and the P of X predicates from one another. And they're both good, they're both okay. So it just depends on what you want to do with the problem. Now the negation of, there exists a movie M that is over 6 hours long. This is an example of an existential, so when I negate it, I'm going to end up with a universal, basically. And keep in mind that I must negate some predicates. So first of all, rewriting there is a movie M that is over 6 hours long, I can rewrite it in the following manner. There is a movie M such that the length of the movie is more than 6 hours, so it's greater than 6 hours. So the negation will be taken in parts. First of all, I negate the existential to become a universal, and then I negate whatever comes after the words such that. In this case, I must negate the length is greater than 6 hours. To negate that, all I have to do really is just interpret what it means to be not greater than 6 hours, well, which means it's less than or equal to 6 hours long. So in other terms, we're saying every movie is not longer than 6 hours. Let's try to negate this time for any real number x. If x is greater than 3, then x squared is greater than 9. Before you watch the rest of the video, try to pause the video and see if you can find the solution to this problem on your own. Keep in mind that this is a universal statement with a conditional. So the universal negation is going to become an existential, and we must leave P alone and negate the Q afterwards. So the original sentence can be written with formal notation, and we can determine that in this case the domain is first, the P of X is next, and the q of x is all the way at the very end. So to negate, we just change the for all to an existential. We leave the p alone, we don't mess with it, and we must try to negate the q of x. Negating x squared is greater than 9 gives us that x squared should be less than or equal to 9. So in other terms, we're saying some real number is greater than 3, but its square is less than or equal to 9. Again, we're not discussing whether the original statement itself or the negation are true. We're just practicing rewriting and finding negations. Why would we care? Eventually, you are going to be asked to find the proof for this maybe. And the very first step in the process of looking for the proof is to determine if your original statement is true or false. And if you think it's true, you must try to prove it. If you think it's false, then its negation will have to be true, and you're going to have to prove the negation, basically.